everyone. Today I'm going to be going over question number 6 from Spring 18 Midterm 2. This is going to be a little more of an advanced question on DP. So let's get into it. We have a 2D grid world, which is an n+1 by n+1 grid, and your goal is to move from 0, 0 to nn. You're given a matrix G, and you know that while traveling out of any given cell, you'll either pay tokens for passage or be gifted tokens. And the value that you'll either lose or gain is going to be in this matrix Gi of J. And Gij will be positive if you gain tokens and sort of negative if you, positive if you gain tokens and negative if you have to pay tokens to move out. And so you can only continue moving while you have greater or equal to 0 tokens. So you can't go in debt. And you can only move down and to the left, represented by I+1j or ij+1. And we'll need to give a dynamic programming algorithm to compute the minimum number of tokens you can start with, such that you'll be able to make a full journey from 0, 0 to nn without sort of going into debt. And so for this, if you want to try this on your own, you can define the subproblems, the base cases, and their occurrence relation. You don't need to prove the correctness for this algorithm, for this question. Yeah, and feel free to pause the video. I'll go over an example at first. So we started with 0, 0, and let's say we start out with 1 token. We can choose to either go right or left, or right or down. Say we go down by picking, sort of going for the highest number of tokens gifted. We'll pay that 1 token, so we'll end up with 0. But we'll now be in this cell. So from there, let's just go all the way right, collecting a total of 7 plus 5 plus 6, so 18 tokens. Then we can go down, ending up with 10 tokens, down again. Whoops, once we go down, we'll end up with 18. And once we go down again, we'll end up with 10 tokens. And then we can step right and down, and then going to 11, then 16, and then ending with 16 tokens on NN. And we don't need to pay the sort of last NN, -4, just because we're never actually going to move out of the cell. And the problem says that you only pay when you travel out of any given cell. So this should give you some intuition for how we're going to define our subproblems and base case. First up, we'll call for the subproblem, we'll say that T of ij will be price, tokens needed to get to nn. So the way we're going to define this DP, the way we're going to solve this DP is kind of backwards. Well, we'll start out at nn, and we'll say that to get to nn from nn, we don't need any tokens. So the number of tokens you need to get from nn to nn is going to be 0, because we're not going to pay this last price. We're not going to pay this last price. And we're going to solve this sort of DP starting from nn and working our way back up the cell to get the minimum number of tokens you need to start with at ij to get to nn. And so let's sort of think through what the recurrence relationship is going to be like for this. Now, one thing you sort of start out with, you'll start out with T of ij, and then we'll know that we know that since we can either move to the right or down, we'll have it be an expression of T of I+1j and T of ij+1. Now, these are sort of the choices you can make. Now, how do we actually write out all the equations around it? Well, another thing we need to consider is we'll need the actual grid world sort of entry. for ij, since we're going to be moving out. And if sort of this, if ij is negative, that means we're going to have to pay. So to step out of Tij, we're going to need to, put a negative. We're going to need to have at least negative ij tokens if g of ij is negative. Right. So if g of ij is negative, if we need to pay to step out of the cell, we know that to get anywhere from point ij, we'll need to at least pay, this. We'll need to at least have this starting value. Right. So, what else can we sort of say about this problem? Well, we can either choose to move right or to move down, and you'll need to sort of take the min over these choices because you want to find the sort of minimum starting coins you need. So if you, if you say that if you move down, then you would need sort of 6 coins to get to NN from the cell below, compared to if you move to the right, where you only needed 4 coins to get to the cell NN from the cell on the right. Then you would choose the min of them because you want to pick the least number of coins. So we'll have a min over these two terms. Generally, when solving these DP sort of subproblems, this is the way I work through it. Is I write down all the terms I'm going to need, and then I work through how I'm going to piece together the puzzle to get to the final recurrence relationship. So we know that the min of the t's is going to be how many coins we need to start at from those cells, and negative gij is going to be how many coins we need to start at our cell. Now, how do those sort of compare? Well, if you needed 5 coins to start at the cell below, right, and you need 5 more coins starting at your own cell, well, then we're going to have to add them up, since if you pay, say for this cell, say that the value is going to be, say that we're computing the value for this cell, right? And we know that the value for this cell is going to be -10. Well, you know that if you need to, since you need to start with at least 7 coins on this cell and 10 coins on this cell, we're going to have to add them up. So we're going to get 17 total. And the way we're going to do that is after taking this min, we're going to subtract. The cost of our current cell. Pretty much, once again, working through this specific example, we're going to see that for this cell, the starting cost is going to be 10 coins. And then to get the starting cost for this cell, we're going to need to subtract from 10 -7. Right. And this is just, right now we've just been looking at negative examples. Let's see sort of if we change these numbers around, let's see what it's going to look like for positive numbers. I think it's always important to consider like all the cases you can have in your DP algorithm, because right now this equation would work for only negative numbers. So if you wanted to sort of find the just shortest path, this equation would actually work this would be correct. However, since you can have positive tokens, that might not be the case, and we'll see why in a bit. So say you're able to get 7 coins here, and you have to pay -4, right? What is the solution to this one? let's erase these numbers. Let's say that T of this cell is going to equal to 4. So this needs to start with 4 tokens. And then G of this cell is going to be 7. So when we do the subtraction, when we solve the equation for this term, we're going to get that you can actually start with -3 coins, which is sort of incorrect because you can never be in debt while solving this puzzle. So we need to somehow factor in that you can never be in debt, and the least amount of coins you can start with is going to be 0. And the way we're going to do this is by taking the max over this min from between this value and 0. So we can only start with a positive amount of coins, not with a negative amount of coins. And this equation is going to do just that, because if we do have a negative amount of coins, if this term is going to be negative, then the 0 is going to come into play, and the solution to this will be 0. And this makes sense because even though you only needed 4 coins to solve the sort of puzzle from this cell, you can actually you can't have -3 coins at this step and then step here to end up with 4 coins, because you would have been in debt from previous steps. So yeah, this pretty much our whole recurrence relationship. To sort of recap the intuition here, this term computes a variant of a min cost path over this grid world, and this max over 0 makes sure that we can never go in debt while we're computing this min cost path. Also, you don't actually care. You don't care about how many coins you've paid throughout this whole array, while traveling. You only care about the starting amount of coins and making sure that you can get to NN. That's why we don't need to have this running sum of cost. All we care is the starting amount, which is going to be given by T of ij. And so the answer is going to be, after we've computed all these values, is going to be T00, 0, and we compute them in sort of topological order, starting at NN, then computing n-1n and n-1, and going in these diagonals until we've computed T of 0, 0. That'll be sort of the order in which we solve these subproblems. Hopefully this makes sense. Feel free to read over the solution in the actual from the actual midterm, or watch this video again. I think these DP problems can be kind of tricky, but hopefully I was able to give you the intuition behind the sort of max of min and how you can modify different algorithms to have drastically different effects. Thanks everyone, and have a good day.